So in part 2, we are looking into how we can do data collection and calculation for the experiment on plate type heat exchanger. Inside the manual, I have selected one exercise by the name exercise number 2, global energy balance in the heat exchanger and study of heat losses. So this is on page 53. We'll go into page 53 and see how we can do the experiment. Now on page 53 we have more details like objective, and if we scroll down we have procedure and data collection table and another table for calculated values. Let's look at them one by one. As for data collection, we need temperature 16, temperature 1, temperature 2, 3, 4 in centigrade, C1, C2, measuring the flow rate in liter per minute. We want to do 4 tests, and the input condition here is T16 55. Once that is reached, we will capture all the other data. Here the condition is T16 52. At that condition we will capture all of these, and then T16 49, 46. So it is like a descending order. We can do ascending or descending order, but in either case we will have variation in temperature of the sensor T16. So we are randomly selecting 55, 52, 49 and 46. So these can change. You can select any similar numbers. So now how to collect the remaining data, we'll go and see on the software. When you click on the software, you see the schematic that is there on the hardware. Again, you have the tank and the pump, have the pipeline. This is the plate heat exchanger, red for the hot water and blue color for the cold water, temperature sensors T1, T2 for the hot fluid, T3, T4 for the cold fluid. You have flow sensor C1 and C2, one in the hot water pipeline and another in the cold water pipeline. So these are all the location of the sensors, and the data can be captured from the right side on the screen. T1, T2, T3, T4, T16, C1 and C2. The units are also here, liter per minute and centigrade. We know 1, 2, 3, 4 location of these sensor, but 16 is inside this boiler tank. So that is the temperature we select for the water to heat before sending it into the heat exchanger. Now to begin the experiment, right now all of these are random numbers, and to begin the experiment we are going to start the pump with the help of this actuator. Take it to full position, and that starts the pump. You can hear noise, and then there is a number here which indicates that the pump has started and the fluid is transported into the heat exchanger from the tank into the heat exchanger with the help of this pump. So you must see a number here, and that will ensure that the pump has started and the fluid is actually going into the heat exchanger. So right now it is 1.5 liter per minute. That is the full speed for the pump. We get this flow rate, and we'll keep that as a constant for all the tests. C2 right now is 0. It means cold fluid is not entering the system. We want to bring in the cold fluid also, so I will open the valve for the cold fluid so that the cold fluid also enters. So this is the valve for the cold fluid, and you can see increase in the pressure here. Again, I will select this to the full open position, so we have the maximum pressure for the water. And coming back here, we see some flow rate for the cold fluid. Alright, so that is the cold fluid flow rate indicated by this sensor SC2. Roughly it is now around 3 liter per minute, and this is stable at 1.5. So we are not going to change these again. both of them operating at full highest level. Now I will cut down this heater. This is the heater on position, so I will remove the check mark, and now the heating shuts down in this boiler tank, and as the water is going into the heat exchanger, it cools, it comes back here cooler. So we will observe a drop in temperature of this temperature 16 T16. So as you can observe here, we started with 60 degrees and now it is less than 60, it is around 57. So we have to observe when T16 comes to a certain selected level, we will capture all of these temperatures. Now in the manual we have selected for test 155, we need to capture all of these. Test 2, 52 and 49 and 46, we have to capture all of this data, and at the same time we also need so that is 55 reached. Now at this point I need to capture all of these T1, T2, T3, T4, C1, C2, mostly constant, but the temperatures are very important to capture it. At the same time I need to click this calculation tab here and capture these calculated values: QH, QC, QL, log mean temperature difference, and U. So these are the 5 calculations that you need for the second table. We'll go here, test number 1, second table, Q hot, Q cold, Q loss, delta T log mean, and U. So the software is fed with the formulae and the constants for water, like the specific CP value for water. So it is doing the calculations by using these temperature values. Q is MCP delta T, so with the flow rate measured by the help of sensor, and delta T measured by these, and CP as a constant supplied. It is calculating and it is giving us the value for the heat transferred by hot fluid, cold fluid, heat loss from the system, and the other parameters, log mean temperature difference and U. So similarly, now for the next test, we have to wait until this comes to 52. We have selected test 2 in condition as 52, so it's cooling and it's coming to 52. When it is around 52, we will capture again all these temperatures. For table 1, click on calculation. For table 2, you need to capture this. Similarly, you will wait further until this goes down to 49. You will capture for table 1 and table 2. Then the last reading 46, you will capture again for table 1 and table 2. So this is how you will do the data collection, and calculation is automatically done by the software, so you don't have to do it manually. So that completes your experiment.